channel, right channel, center.
ENVTuber 一問一答自己紹介
Yeah, and the tape's
それじゃあ
rolling.
行くよせーのお名前は
Katt Phloxworthy.
呼び方は
Just Cat is fine.
あなたは何系 VTuber?
Nerdy cat girl who features spaceflight.
誕生日は
May 4th.
年齢は
Older than Pneumatic.
性別は
Transgender
身
female.
長は
4 foot 11.
出身は
Sacramento County.
チャームポイントは
Dialogue hair clip.
突然ですがモノマネどうぞ
Yeah, what's up, Dad?
活動場所は
Twitch, Twitter, YouTube.
はじめの挨拶
Thank you for joining me.
終わりの挨拶
Bye.
推しマークは
Not at present.
配信タグは
Catlight feed.
ファンアートは
Cat pics.
ファンネームは
Cat's apprentices.
好きな色は
Iris Indigo.
好きなことは
Vintage computers and
得
video.
意なことは
Technology.
ここで一言愛の告白好
I love you.
きな食べ物は
Ethnic foods.
好きな飲み物は
Craft soda.
好きな漫画は
Pizza 10.
好きなアニメは
Planet.
好きなゲームは
Left 4 Dead 2.
好きな音楽は
Classic rock.
苦手なことは
Human stupidity.
尊敬するのは
Space fairy people.
叶えたい夢は
ISS crew
最後にみん
interview.
なに一言どう
Thanks
ぞ
so much for your support and a final status check.
Go Atlas.
Go Centaur.
Go Katt Phlox.
You have permission to launch.
3, 2, 1. RD-180 ignition. Booster ignition and liftoff of Atlas V and Centaur. Hello, everybody, and thank you so much for joining me. Hi, everybody. Katt Phloxworthy here. Yeah, I'm pretty stoked to see all you guys come here because for a couple things. One, I made a few changes, both to the look of the stream itself, to the stream itself. Plus, I've also made a few changes in. I may need to make a few more changes, most notably on VBridger. I just hope it actually looks okay. And hey, Britton Holden, how are you doing? And also made some. I made some corrections on here. And hello, Master Chaos, how you doing? Anyway, made some changes and hey, Jessica, how you doing? Anyway, just I made some changes to the encoding for the. I had to basically redo some of the slates in there, and decided to simplify things just a little bit. And it looks pretty good, I think. Anyway, I hope you guys are liking it thus far. If we put an electron as a booster for the proton, would that make a hydrogen? You know, that's a good question. Good point. That's true because, well, neutron though. For those people who don't know, that is in the process of being made for larger payloads than what Electron can do, and it's being powered by a bipropellant of liquid oxygen and liquid methane. In the meantime, we're going to go ahead and join the folks over at the Mahia Peninsula down in the southern tip of New Zealand, where they have the rocket on the pad, getting ready to launch. And this is called the Harvest Goddess Thrives. So let us go ahead and oops, hang on just a sec. Let me make sure I got that right. Here we go. And oops, hang on. Let me fix this real quick here. I thought I had it fixed, but oh, let me double check one other thing here. It shouldn't take too long, I hope. Plus, I'm also going to put this in. Oh, shoot. This is going to be. I've just pressed the wrong. Yeah. Let me see what the hell is going on here. I thought I had it going earlier, but. I just realized I need tools. Mr. AV is on. Let me go ahead and get into the studio machine, make sure that it is actually sorry about the stuff. I realized as I was getting ready, I actually had to reboot the machine because The machines that I have now that do the VTubing and studio machines, I actually have to reboot the machine when I first bring the machine up, because for whatever reason it's not seeing the stuff going out. Not too long ago, a somewhat conniving fully assembled neutron on the pad was made by someone on space Twitter, and it may have been the reason why behind the spike in RKLB stock, Rocket Lab stock. It wouldn't surprise me because Rocket Lab investors are notoriously out of touch. Why does that not surprise me? Why does that not surprise me at all? I need to do something real quick here. I'm going to go ahead. I need to go into the scenes that set up that bring in the sources here. There we go. Okay, something is definitely not right here. That's not what I'm looking for. Let's see. Convincing. Okay, that makes sense. See what's going on. Why am I getting nothing out of that other machine? Let's go ahead and drop Distro AV off completely. Turn it back on. And I'm going to go back, and since I'm in studio mode, I can still look at this. Actually, what I'm going to do is I'm going to restart the local OBS Studio process that's pulling the feed from YouTube. Hang on just a sec here. You won't see all this. I don't know why, but it's not actually sending it out to where it's supposed to go. Let's see. Like at a first glance, it was convincing, but you spend 5 seconds to look at it, and you can tell it's an edit. Oh, oh, I'll bet. Anyway, I'm waiting on. I'm going to go ahead and fire up OBS Studio. That is pulling that down one more time. Okay, we need to re-pull down the feed. But thankfully, we have about 10 minutes left until launch. And best I can tell, they probably have already gone into Oh, cool. I actually still had it in here, but on top of that, I need to make sure I have. Okay, we've got that. Now let's see if we got... What is going on here? I don't know what's happening here, but... Oh, hang on a sec here. I'm going to try one other... I'm going to check one other thing real quick. This is... a bit embarrassing because it worked earlier, but that's when I didn't have the network interfacing working properly. And let's see. Let me look at one other item here. there is... I need to take a look at one other item here while I'm here. I am really sorry, everybody. This was, I mean, I thought I had everything set up, but let's see what's going on here. Let me double check one final item here. Oh, good, thanks. Don't worry. Thank you. Appreciate it, because next. Just double checking all the... But it is actually, it looks like it's sending it out the right way. I'm just not picking it up for whatever reason. I don't understand why. Because normally that should never be a problem. I'm gonna restart the program again and see what's going on here. Yep, it looks like we're in better shape now. Hang on. I don't know what happened, but I guess I needed to make a Nope, I need to go through a different window here. But yep, I'm in much better shape. Sorry about that, guys. Oh God, I'm so embarrassed about this. Okay, we'll go ahead and head on over there right now. There we go. I think I may not have any audio here. Oh, hang on. One other thing I need to double check is go into... I should be hearing something right about now, but apparently I'm not getting anything. I'm going to switch back over here for just a sec here.
T minus 11 minutes. We'll throw it back to mission control.
We're good. As
more.
it turns out, there is audio, so my apologies for that. There actually wasn't anything being said at that point in time. Anyway, for those of you who don't know about this vehicle, this is the Electron rocket, which is a small sat launch. Let me also want to turn off studio mode. There we go. Basically, so they have, they're now at a hold. Basically, there might be an issue going on that they need to diagnose and see if there are any issues and rectify them as needed. And at that point, they will reestablish a new T0 and get ready to release the hold. At T-minus 11 minutes, what they usually do is they do a go-no-go poll to make sure everything is good to go for launch, whether it's the vehicle on the ground, all the systems on the ground, the people in the blockhouse, as well as the range, which is where the vehicle will fly once it gets launched. Sometimes they'll talk about range red or range green. Range red means like, say for example, somebody decided to put their boat out there when they shouldn't have, And range green means it's completely clear, ready to go. That includes ground, maritime, and air-based traffic, making sure that they don't actually foul the range to make sure so in case there's a problem, nobody gets hurt. And also on top of that, people who have any sense will actually launch over water wherever possible. And yeah, I'm I'm a little merciless when it comes to certain other people who launch space vehicles. Anyway, the Electron rocket.
We want to provide you an exciting update on one of our spacecraft.
Let's see what they have here.
Last year, we built 2 identical spacecraft for NASA and UC Berkeley's Space Sciences Laboratory as part of their ESCAPADE mission. Now, ESCAPADE stands for Escape and Plasma Acceleration and Dynamics Explorers. These 2 spacecraft, named Blue and Gold after UC Berkeley's school colors, will go to Mars to investigate Mars's hybrid magnetosphere.
Now, ESCAPADE is part of NASA's Small Innovative Missions for Planetary Exploration program, which really emphasizes getting high-quality science done with smaller, more agile missions.
And by flying these twin spacecraft in tandem, they'll be able to capture a much more comprehensive picture of the magnetic fields and plasma dynamics around Mars, measuring things like the energy and speed of particles being lost from the atmosphere, and generally getting a better understanding of how the planet's climate has changed over time.
Our Space Systems team is performing routine maintenance and tests, preparing the twins for their journey back to Florida for launch. It will no doubt be an extremely proud moment when we get to send these 2 to space. Stay tuned for more updates on this incredibly exciting mission.
And if you've ever wondered how we've been able to make such massive strides, anyone who works here at Rocket Lab will tell you the same thing. It's because of the incredibly talented and dedicated people who work here.
And we're always looking for new talent to join the team, both on the launch side of the business as well as across our Space Systems division that designs, builds, tests, and operates spacecraft. Let's take a look at this breakdown of what it's like to work in Space Systems here at Rocket Lab.
I think the fascinating thing about the space industry, especially in the last 5 to 10 years, is that there's been such a boom of technologies that have been developed for space in particular. There's a massive difference in what the industry is now.
I think right now is a very interesting time since we are doing production and development kind of all at the same time and really kind of driving towards what's going to get us to that end-to-end space solution.
I haven't worked at a company where you have places in New Zealand, in Canada, on the East Coast, on the West Coast. It's a small company, but it's got a huge footprint.
Rocket Lab is in growth mode constantly. I've been here for a little over a year now, and just seeing the big difference between day 1 to where we are today is exponential, and it's only going to get better from there.
Everybody's very, very dynamic, very agile. New ideas are always well accepted. So, you kind of have to thrive in a very dynamic environment.
My tech team feels like a team. The engineers work hand in hand with us. Everyone kind of works together to meet the same goals. We all have different jobs, but at the end of the day, we want to make sure that our jobs are done so we can move on to something new together.
The expectation is large on individual employees. We run a tight ship across the board no matter which team you're on. And so there's a lot of opportunity for individuals to show what they excel in and to kind of reach out and expand their specializations.
You can be a fresh engineer, but as long as you show passion and drive and curiosity, you'll succeed here and go a long way.
Not only are you surrounded by truly exceptional technical talent, but it's incredibly supportive. That's been like the cornerstone of why I feel like my experience here has been so valuable.
I never would have imagined myself being here in this moment. It just feels like I'm living my dream. Not to sound corny, but it really feels that way. Every time I work in there and work on the spacecraft, it's like, wow, this is really going somewhere. And it's what I've always wanted to do, so it's really enjoyable.
Rocket Lab has a good head on its shoulders. I think we know exactly where we want to go. We know exactly how we want to get there.
you want to go fast, you go alone, but if you want to go far, work with a team. This is a company that needs to go far. We're going to Moon, we're going to Mars. We have to go far together.
This company is really expanding in a way that includes multiple facilities, multiple departments, and if you're looking for something that will keep you grounded, but also will allow you to explore, this is exactly where you need to be.
It really is all about the people in the team who drive our technology forward and support some really cool missions in the process. So whether you're straight out of college or a vet with 20 years of experience, everyone works together to tackle the same problems and advance the same mission. And if you're interested in joining them, there's likely a role open for you. Check them out on our website, rocketlabcorp.com.
And it looks like looks like, from what I could tell, it's probably a weather issue right now. But anyway, what you see is the Rocket Lab Electron launcher. You see, in fact, those normally what you would see, this would be black from top to bottom, and those big white stripes there aren't paint. That's actually frost. Basically, what happens is that this rocket uses a bipropellant of RP1 or refined petroleum 1 or rocket propellant 1, depending on who you ask. It's basically a highly refined form of kerosene, and all that white stuff on there. Like I said, it's frost, and that and under that is the oxidizer, which is liquid oxygen, which is very, very, very cold. And basically, what we're waiting on right now is they're trying to find out when the next opportunity to launch during the course of this launch window. But anyway, this is a very small rocket. As far as its layout is concerned, it very much resembles the Falcon 9, where it has 9 engines on the first stage. And one on top of that, the first stage uses sea level optimized engines, whereas the top stage has 1 engine and is vacuum optimized. Let me take a look at something real quick here. Sorry. Hey Kev16, how you doing over on YouTube? Hope you're doing well. Anyway, basically it is about, I'd say about 2 or 3 feet in diameter and about 60 feet tall. And and since it's such a small vehicle, they don't actually use what are called turbo pumps, where they burn a bit of the propellants to spin a turbine, which then drives a pump to deliver like the RP1 and liquid oxygen into the combustion changer. And in this particular case, what they're using is electric fed pumps. And from what it was rather interesting hearing Tim Dodd about, like for example, if you look at the Soyuz vehicle, that ones that take the eponymous crewed vehicle up there, along with its uncrewed variant Progress, which is its cargo variant, it must use on the order of multiple megawatts of power if you ran this with electricity, which would probably be impractical to do. So, looks like they've reset the clock. I guess we're waiting on a T-minus 12 minutes. I don't remember if they do the go-no-go poll at T-minus 12 or T-minus 11. And at that, what they're doing during that particular period is to make sure, like I said, all items are go, like whether all the systems on the vehicle, all the systems on the ground, all the support systems on both sides are good to go. And on top of that, make sure that the range, which is the area immediately in the path that the rocket's going to fly through, will actually be clear. It's very interesting. The smallest launches are almost always between 55 and 70 feet tall on average. Just shows the lower limit on Keralox launchers. That is true. Most of that stuff that you do that's really, really small tends to be like hypergolics, I would believe, or solids. In fact, the Minotaur that Northrop Grumman uses, which is an adaptation of retired missiles, I believe Minuteman missiles. Those are all solid, and I've seen some of them, some of those. And on top of that, another thing I noticed about that one is it uses multiple stages beyond, like, say, 2 or 3, like 4 or 5 of them. And watching them stage is like they go bam, 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 bam. It is insane. And on top of that, the acceleration on those things must be absolutely insane. And if they call a range red, we'll go ahead and end the stream. But since I got to get,
the team have identified the reason for the hold, and the clock has been reset at T-minus 12 minutes. Standing by now for the go no go poll in mission control shortly.
Oh, they're about to do that go no go poll. Sorry about that. Yeah, I wonder about the weather, because that's kind of interesting, to say the least. High energy densities when with
LD and mission code. Just a heads up, we will be picking a new T0. We are looking at 4 local time. So I'm repeating, we will resume the count, and we are looking at a T0 of 4 local time.
So we got about 17 minutes until launch. And they will resume the count at right around 2 minutes to the hour. Anyway, high energy density with low efficiency. Gotta love my solids. Yup. Oh, I was watching one of those. I watched a video, and I read about this before, and they're talking about particularly the speaking of solid propellants. There's a company in Henderson, Nevada called Pepcon. What they did is they made solid propellant components for the space shuttle. In this case, okay, there we go. They've just
And to all operators, LD and mission code. I can confirm I'm actively monitoring mission code, LV code, and safety net.
So it looks like they've resumed the countdown. Anyway, Pepcon, they make one of the components for the space shuttle's fuel system for the SRBs, the solid rocket boosters. They use a fuel of aluminum powder, and the oxidizer is potassium perchlorate. Excuse me, ammonium perchlorate. I'm sorry. And after the Challenger accident back in early 1986, apparently they had
heard from the launch director. The count has resumed, and we are at T-minus 15 minutes in the count.
Anyway, like I was saying, what had happened was that during the time that the space shuttle was grounded the first time around, when with the destruction of Challenger, they apparently never stopped making the ammonium perchlorate, and it built out by quite a bit. And what had happened was that at one point they there was a welding accident at one of the places near that, and they had this just enormous amounts of the material all over the premises, and it was so bad. When the fire started, it was starting to spread around all the other stuff around, and one of the explosions was so powerful, it destroyed, completely leveling a nearby building. Time for lunch. I often wonder why there aren't many solid orbital rockets in the Western private launch market, especially if it's only converted, decommissioned ICBM and Vega. Oh, that's true. Hadn't seen the Vega ones because I know for the longest time they were having problems getting those off the ground and getting to orbit. Oh dear, oxidizing fires are never good. No, not with anything that potent. We're talking, I don't know what the actual, with the various oxidizers, like the solid oxidizers, like you hear about potassium chlorate from a certain black Scottish cyclops versus say ammonium perchlorate, which is what's used here. Potassium chlorate, actually, I'm sorry. But yeah, I think it's another oxidizer. So anyway, what happens with this vehicle? It will launch from the moment it launches up. It will. We're coming up real close, within about a little more than a minute until the go no go poll. What they'll do is they launch the vehicle. They'll launch the vehicle. Go through go through Mach 1 and Max Q. Things like they just fixed the second stage on Vega C. It's been doing finally. Oh, that's good, because I know the second stage was having all sorts of problems. The last one I actively watched on my own, it was it failed. It never lit. Anyway, the at about 2.5 minutes after launch, the second stage with the vacuum optimized engine, which is called the Rutherford engine, which is named after a New Zealand rocket scientist. I hope you hear from the oh my thing. We're seeing the footage of this. Wasn't that at the old Thiokol facility? I don't know. I really don't know. I hope that we hear the pumps spin up again. Oh, here we go. T-minus 12 minutes and counting.
LD and mission code. We are proceeding now with the go-no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Recon.
Recon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
And LD sub.
LD sub is go.
The go-no-go sequence is complete. We are currently T-minus 11 minutes and 16 seconds and counting. We go for terminal count auto sequence at T-minus 10 minutes. From this time, the 3-bed procedure is in effect.
And that's exactly what we want to hear. We are go across the board for Electron's 69th launch. No issues with the rocket or pad systems. The payload is healthy and the weather is cooperating for today's launch.
Oh, that's
We are
good.
now at T-minus 10 minutes to liftoff, and things are looking appropriately green for the Harvest Goddess.
Nice. See, it says, I hope we hear the pumps spin up again. I remember that. I remember ever since Falcon 9, I badly wanted to hear the turbo pump start again on the on every rocket that uses them. The Falcon 9 Flight 1 turbo punch startup is beautiful, and you can hear them on Delta IV Heavy flights, especially when you throttle up the core. Oh yeah, that's true, because they spin that thing up very. They sped it up early, full during the early stages of the liftoff, and then they throttle it back, the center core, while the side cores are still on. T-minus 10 minutes and counting, entering terminal count. And we'll hear more throughout. And just before the vehicle launches, you will see a whole bunch of water start to flood the pad. What that is a deluge, which is used to absorb acoustic energy to keep it from damaging the vehicle or the launch pad, as well as anything right around it. And you'll see that a lot on any other spacecraft as well, because they put out lots and lots of noise. Never heard of Rutherford being a rocket scientist. I thought it was a reference to a scientist that provided that atom that is mostly empty space.
While we wait to hear
with
an
the gold
update
photos,
from
right?
Mission
It's a different
Control
one.
about today's launch from LC1, over on the east coast of Virginia, our third launch site, Launch Complex 3, is progressing smoothly.
We're almost ready to cut the ribbon on the launch site for our new reusable rocket Neutron, our dedicated launch, test, and landing site for future missions. Here's more.
My name is Sean DeMello. I'm the Vice President of Neutron Development here at Rocket Lab. LC3 is located at the Mid-Atlantic Regional Spaceport at the Wallops Flight Facility in Virginia. We chose Wallops for Neutron largely because it is a site that has an immense launch capacity and availability. There are a very few number of operators. In fact, we're the only ones operating out of Wallops right now going to orbit. So it is a very favorable choice for a new launch vehicle
Northrop
requiring
Grumman.
a lot of launch availability. So Wallops is unique for Rocket Lab in the fact that we can launch Electron, HASTE, and Neutron all within the same overall launch complex itself, and we've got adequate propellant storage that allows us to turn around vehicles 24 hours apart. We have a lean and mean team out of Wallops who've done everything from designing the systems on the launch pad through to now actively constructing it and operating it. Here on out, our objectives are to complete all the system activation and
But they wanna see
performance
the
test
HASTE flight
against all our
profiles.
test
I'm waiting on that
objectives.
one too,
Once
yeah.
that's completed, the site is ready for rocket and will be operational. And with construction and activation in full swing right now, we look forward to opening the pad here this summer.
Ooh.
We can't wait for Neutron's first launch.
Sorry about that. I needed to get something to munch on real quick. What profiles do they even have? What profiles do they have to consistently test hypersonic vehicles? I need to know. That's a good question because I know they talk about a lot of hypersonic test vehicles, especially considering for the reentry profiles. They do that all the time. And of course, they're not. They're probably what they're doing is they're putting hypersonic space, hypersonic air. Well, actually, I'm not sure if it's necessarily hypersonic airflows when they do on ground testing. But I imagine they put a lot of the thermal stuff in there. I imagine they place enormous amounts of pressure on there. They have to put a lot of pressure on there because the vehicle's barreling into the atmosphere starting at Mach 22 when they're coming from standard Earth orbit, and much higher when it's coming from either lunar or Mars orbits. They're pulling out that is the strong arm, which holds the vehicle when it's loading up and loading fuels.
Card.
Avionics LD.
Avionics terminal checks complete.
Copy, thank
LD GC on mission code.
GCLD.
LD, the hold down mechanisms are armed and the strong back is retracted for flight.
Copy, thank you.
Okay, it is now T-minus 4 minutes on the countdown clock to launch as we approach liftoff time here in New Zealand. At around T-minus 2 minutes, Electron's autonomous flight computer will take over the final sequence of launch preparations. Shortly after that 2-minute mark, we should hear the call that LOX loading is complete, which means that Electron is fully fueled for launch. The next gate after is the signal that the first and second stages are pressurized for launch. And after that, we wait for the 10-second countdown to liftoff run by our launch director. Let's listen in to Mission Control now for these final steps in the sequence. We'll be back with you after liftoff. Go Electron.
Understood. Thank you, GC.
Am I muted? Yes, I am. Thank you for the heads up. Yeah, basically what's going on, what we're seeing right now is, for those who don't know, the those clouds that you're seeing at the top of each of those two white bands, that's gaseous oxygen that is boiling off of each of those two stages as the vehicle is being filled up and topped off with liquid oxygen. There isn't any insulation on those stages, so they pretty much have to keep it'll boil off as the vehicle is filled.
Code. From now on, there should be no red flags on the critical LCCs.
And again, like I said, at
code.
LD VCOM.
Lock the auto sequence and confirm.
Auto sequence is locked.
And VCOM, please confirm all flight computer ASCOs are green.
All ASCOs are green.
To all operators, we are go for auto sequence start at T-minus 2 minutes. LDs go for launch.
The LD launch director has called ready for launch, with auto sequence starting at about T-minus 2 minutes. And during that last 2 minutes, they will go ahead and they'll terminate replenishing. T-minus 2 minutes of counting. They're now at auto sequence start.
The vehicle is fully on internal power. AFTS is green and enabled for flight.
They're terminating the liquid oxygen fill in just a moment. Looks like they've done just that.
Lock slot is complete. System is in recirculation.
We're coming up on T-minus 1 minute. They've gone into circulation, meaning that they're no longer unloading liquid oxygen onto the vehicle. T-minus 1 minute and counting.
Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
We have tank press on both stages. T-minus 30 seconds.
T-minus 20 seconds and counting.
15. 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. Ignition. And liftoff of Electron carrying the Harvest Goddess Thrives vehicle into orbit, and the vehicle has cleared the tower.
Beginning pitch over.
They're pitching over to place it above water in the event of an abort scenario. And about 50 seconds into the flight, they will breach Mach 1, going faster than the speed of sound. Shortly thereafter, being max Q, or maximum aerodynamic pressure, the highest amount of aerodynamic stress that the vehicle will experience during its ascent.
The Harvest Goddess is on her way to space for IQPS. Electron has launched cleanly off the pad at Launch Complex 1 and is now coming up against 700 kilometers per hour. In just a second, we should hear from our operators that Electron has reached max Q, which is the point in the flight when Electron is experiencing maximum aerodynamic pressure.
Vehicle is
It's the
supersonic,
first
approaching
milestone
max
It has gone past Mach 1, and we're about to go through the area of maximum aerodynamic pressure, or max Q, momentarily.
Cleared max Q.
They just called max Q. The next event that's going to happen will be.
Through max Q for Electron,
We have about a minute left in the burn. The next milestone will happen at that point, where the engines will shut down in an event called MECO, or main engine cutoff, followed by staging with the separation of the first and second stages and the ignition of the vacuum optimized Rutherford engine shortly thereafter. And that is always a sight to behold.
Electron and IQPS onward to our target altitude for this mission. Let's keep an eye out now for the view across both stages as those events take place.
Holding nominal, stand by for MECO in roughly 30 seconds.
And one of the things they'll also do is they will throttle the engines down on the first stage just prior to MECO. And like I said, this is always fun to watch. Here we go.
Burnout detect mode.
So we're about to experience a shutdown on the first stage engines, followed by separation of the stages.
MECO confirmed.
They called MECO. We see MECO. Staging.
Stage separation.
There goes the pumps, and there goes the second stage, and there it goes, leaving the first stage real fast and far behind.
A clean separation from the first stage as planned, and a beautiful
And
start
this is an interesting view because I've never seen this view before, and oh my gosh, it looks gorgeous.
Is now at more than 8,000 kilometers an hour with an altitude of 95 kilometers after that separation event. Next up will be fairing separation for Electron when the rocket's nose cone halves split and fall away to expose the Kushinada
We should be seeing the payload fairing split open momentarily. There's the interior of the fairing. There go the fairing halves. And there go the fairing halves falling back to Earth.
And there you have it. Electron's two fairing halves have jettisoned from Electron, and on your screen you'll see the Harvest Goddess safely attached to the kick stage and ready to make her debut on orbit. Taking a look now at the propulsion monitoring camera at the bottom of stage 2 shows that Rutherford is continuing nominally since engine startup, which happened just a few moments ago.
Wow, they really did a bang up job of getting more visuals coming out of that. That rectangular thing in the center lower portion of that, right by the engine, is a battery. There's one just like it on the other side. At that point, you'll see a little bit further up, you'll see an item that says battery jettison. At that point in time, what will happen is that battery and the one on the other side,
we have another 5 minutes
shortly
to
before
go for the second stage
switching over to a set of batteries inside the vehicle itself, they will separate and fall away.
800 pounds of force in the vacuum conditions of space, with a specific impulse of 343 seconds. Now, specific impulse is a measure of performance in telling us how efficient an engine can be.
The fact that they can actually give you sound is also pretty cool. I saw that the last time one. Another battery to the ocean. Yup. Actually, 2 of them. Or technically 3 once you consider the second stage, although the second stage will probably burn up before it even has a chance to do that. And I think even the batteries will probably burn up before that happens too. Because we've already passed 11,000 kilometers an hour.
One of the pretty special things about both our sea level and vacuum optimized Rutherford engines is that they're actually battery powered. The propellant pumps on these engines are driven by brushless DC motors powered by batteries. Now, since the amount of time the second stage engine needs to run is longer than the capacity of the first battery packs, Electron needs to perform a power switch over to a fresh set of batteries to keep the engine running. The flight computer does this while the engine is still burning hot. That's why we call it the battery hot swap. In a few moments, you should hear that call out from our launch operators, and if you keep an eye out on your screen, you should see those batteries eject in the next few moments.
From the throwing car batteries into the ocean for rocket batteries, humanity is beautiful, isn't it, though? So they're about to do... But anyway, what will happen soon is, like I said, they're getting ready to do a battery hot swap. When they switch to a set inside the fuselage itself.
In roughly 30 seconds.
And the jettison should be happening momentarily, and you'll see that, and another one on the other side
down.
fly away. Standing by. Well, I guess I was wrong about that.
Confirm hot swap successful.
I guess
nice and clean with that battery hot swap there, and one of the final launch milestones completed on Electron for its 69th mission to space. We are cruising along now at 15,000 kilometers an hour at 220 kilometers in altitude. Just 2 more key events remain for this first stage of the mission. That is SECO, or second engine cutoff, followed by stage separation, where Electron's kick stage separates from the second stage and gets ready to deploy the payload into orbit.
And like I said the last time, basically they have to do that hot swap, not just because they need to have a fresh set of batteries.
Views of Earth from space from our onboard cameras. We touched on it a little bit at the start of the show, but right now Electron is running fully autonomously. What that means is our extremely talented GNC engineers have completed all the analysis to determine how to get to the specific place in orbit, and right now Electron's flight computer is running its algorithm in real time to fine-tune its performance and land Kushinada 1 on its final deployment orbit.
Anyway, like I was going to say, like I said the last time that I did one of these, the batteries, the battery has to change out for 2 reasons. One, they need another battery source to get to keep the keep the battery the vehicle flying.
Into flight, and you can see on the right of your screen, Electron's second stage has around 13% of propellant remaining. Much like the first stage, there's no sense in carrying dead mass to orbit. So shortly we will separate the kick stage and payload from stage 2. We are soaring now past 22,000 kilometers per hour at an altitude of 230 kilometers above Earth.
With less than a minute left on this engine burn, we're approaching SECO. The engine on your screen there will power down and shut off just a moment before the kick stage is separated into a transfer orbit. Now, it may sound simple, but this is a very precise maneuver, and it's important that the kick stage is exactly where it needs to be for the next phase of the mission. Let's listen back into Mission Control for that SECO call and stage separation confirmation.
But like I said...
SECO confirmed.
Oh, we got SECO, second engine cut off confirmed.
Stage separation confirmed.
And they've separated from the second stage?
With that Rutherford engine cold, we have heard confirmation from Mission Control that SECO has been cleared, and we've had a clean separation of the kick stage with the QPS SAR-12 to a nominal transfer orbit. What that means is that the Harvest Goddess and the kick stage are on the planned trajectory to transition from this initial elliptical orbit to its final desired circular orbit at 575 kilometers. This takes about 40 minutes or so to complete before the kick stage ignites our Curie engine to perform a circularization burn, landing us in our 575 by 575 kilometer orbit.
We'll be back with you for those final moments of the mission, but for now, you can follow the path of the Harvest Goddess in real time with our animated tracking graphic. And hey, while you're waiting, go check out the career section of our website to see how you too can make a difference in space.
We'll see you back here soon for payload deployment of QPS SAR-12.
The only thing is, I don't know, excuse me, I don't know if they actually do, I don't know if they're going to do an actual visualization of the deployment of the payload They didn't do it last time, so I can only assume that they won't this time. They'll just have they'll have a simulation of that. But like I was saying, the reason why they have to do the battery detachments partly is to mainly because they not only need to cycle in some fresh batteries, but also, like I said the last time, it's because since it's using batteries in order to move electricity from there into the pumps on the Rutherford engines. Unlike, say, a Falcon 9, which is burning Kerlock's propellants, that stuff's gonna, along with the stuff that's going into the main combustion chamber itself, that's actually going to deplete the amount of the amount of fuel and oxidizer out of that. Not so with electricity. That stuff is still there, and it's still going to weigh it down. They gotta jettison it in order to even to get rid of that extra weight. Because if they can't use it anymore, there's no point in keeping it. So they drop it off, and then of course there's the remaining battery in the fuselage itself, and that is what keeps the pumps running on Electron as it continues to go uphill. And so anyway, I'm actually thinking of just going ahead and calling it a night tonight, because I have to get ready for tomorrow. Because not only do I have to take myself to work, I also have to take Rumi to work as well. So what I'm going to go ahead and do is that, and I'm going to put this back to the solo one. I'm probably going to have to do also a little bit more. How does the mouth movement look? I'm still probably going to have to do a little bit more messing around with both VBridger and VTube Studio to see how well they talk to each other. And yeah, thanks for understanding. Yeah, it looks great. Thank you. But anyway, on that note, what I'm going to go ahead and do is I'm going to shut down the other VTubes. OBS Studio. Excuse me. Where did I put the damn thing anyway? Found it. Yeah, I also noticed that there's some other music. I'm not sure how many of those pieces are new from like this one is. It's also made by Tim Dodd, the Everyday Astronaut, who does a lot of educational content, and I've actually helped with some of the work on his stuff during the course of being on his Discord server. So anyway, so I'll have to check their music out and possibly get it added in, and hopefully also before too long, I'm probably going to do some more Half-Life Opposing Force, and of course some of the other games I've got, and also on top of that, I should have a bit more money coming out of my next paycheck that I can use possibly for some games. More on that the closer we get to that. That'll be a little more than little less than 2 weeks from now. So more information as I get close to it. But in the meantime, we're gonna go say hi to someone on the way out. Hang on a sec here. Thank you for stream, Cat. Another banger saying, oh, thank you very kindly. Yeah, it's this one I completely forgot about. Thanks as always, Red Blue Fire. Always good to see you. Let me see who we can go check in on. But anyway, the vehicle that's going up there is a synthetic aperture radar imaging system, and I believe it's being used like for agricultural stuff. And it was made, and I'd have to go look at the name again, but it's always but basically it goes and takes imagery over the course of sometimes may do it on orbit, kind of like I can't remember the one that was doing that, and unfortunately they may be doing some without going into too much detail as to why. but some of the stuff that's being used for agricultural and weather stuff may be going away for various reasons. But like I said, I am not going to go into that for obvious reasons, and possibly other reasons that I might find, and much to my complete chagrin, we'll see. And anyway, let me see who we can go say hi to over on Twitch. If you know, you know. And if not, you can probably extrapolate. Fair enough. Yeah, that's, let's just say certain people think that there are better things to do with our the country's money. Again, I'm not going to talk about it. For, like I said again, obvious reasons. I'm going to take a look at one here. Nah. I know who we could go see, I think. I want to see Move Merrily. I actually got to say hi to her over at SAC Anime back in January, and at the time we actually showed each other our then forthcoming models. So anyway, I just want to go check in. We're gonna check in and say hi to her. Let me go ahead and do the usual pre-end of stream activities. There's a raid text message for those who don't have a subscription, and here's one for those who do. Yeah, that one is the right one. Okay. Go ahead and copy it myself. In the meantime, we're going to do the final events here. Let's see. I'm going to go ahead and get this started. Actually, how long has it been up, I wonder? Ooh, she's been up for almost 4 hours. So, that may not necessarily be... Mute mine for just a second, see what's going on her side of things. Hang on. Yeah, it looks like she might be ending soon. I don't necessarily want to jump. I don't want to raid into someone who's about ready to head off for the night, and I really want to raid her. I'll probably do it some other time. But in the meantime, let's go see who else. But yeah, go check her out in any event, because she is. She's lately been playing. Liza P. Let's go check in with someone who's another cat, K-A-T-T. In this case, it is Cutie Cat with a K at the head. Let's go and check. Let's do that instead. Let's go ahead and she actually drew and rigged her own model, and I like it. Let's go ahead and go and raid her and get ready to go ahead and start the raid. Thanks again so much as always. I'm probably going to go ahead and do another round of opposing force, like either tomorrow or the following night. But in the meantime, thank you so much for coming on. Thanks for coming on in. As always, I like to say Slava Ukraini, and I hope you have a great evening, and I hope to see you next time. And until then, I hope you have a great one, and hopefully I will have something before too long. So until then, have a great one, and I will see you then. Bye.